A key concept in all operating systems is the process. A process is basically a program in execution. You might be having lot many programs in your drive, and out of that, lot many programs or lot many applications in your drive, like word processor, WhatsApp, you have lots of games and many more things that you have. But then the ones which you click and the ones which you are presently running them is the one in execution. Associated with each process is its address space. So whenever you want to run a process like WhatsApp, you know that you need to send a message to your friend. It has lot many things to do. It needs to just create the message, package the message, send it over the internet, and see that it is reached the destination. So lot many instructions to follow. So the process needs to know what all instructions it needs to follow. If it is a simple word program, it doesn't need to package the message and then send it over the internet. Instead, it needs to just remember all the formatting and save it in a drive. So thus, every process needs to know what instructions it needs to follow. If it is an image, it needs to display it finally. That's it. So associated with each process is its address space. Basically, address space is a list of memory locations from 0 to some maximum which the process can read and write. So what does this address space contain? This address space contains an executable program. Not only an executable program or instructions, instead it needs to also contain the program's data. For example, the program needs to do some mathematical calculations like addition, multiplication, then it needs to know what data on which it needs to do the calculations. So therefore, the process also needs to know the program's data. Now, it also will have a stack. Now you need to understand what is the order in which the instructions need to be followed. Thus, it has a stack. Also associated with each process is a set of resources, commonly including are the registers. Now you need to do mathematical calculations, you need to load each data into one register and then perform the operation like addition, subtraction, multiplication, etc. Now, apart from the registers which contain your useful data, it also will contain data like what is the current instruction that is being executed, where the stack is standing right now, how many more instructions it has to perform, and so on. So the important registers that needs to be remembered is the program counter. The program counter always points to the current instruction that it is executing. The stack pointer points to the basically the number of the instruction that it is executing. A list of open files. Now if you just execute some program, it's not necessary that you're always working with one file. Sometimes it requires many more files to be open. For example, if you want to work with a C program which starts with hash include stdio.in, it has string.h, it has math.h, etc. So it needs to open a standard input file, read all the instructions, and fetch you the needed instruction and attach it to a C file. It has to read the string file, get all the instructions, attach it to your the file. So like that, it needs to perform operations on many more files. So, but it needs to remember what all files I opened. Therefore, it maintains a list of the open files. And it also has some outstanding alarms. For example, if you just talk about Windows update process, which you have always been saying that let me do the update later, it keeps on reminding you that there is an important update that is waiting for you. You need to immediately say yes so that I can perform the update. Otherwise, maybe some programs might not run. Similarly, when you're shutting down a system suddenly, it will remind you that there are some files which have unsaved changes. So it lists down all the files which are open, which have some unsaved changes. So therefore, every time it requires you to do something, it gives an outstanding alarm. So process also has a list of outstanding alarms that it has. For example, if it is printing a page and the printer is running out of the paper, maybe it has no ink or some head is jammed and it's not moving, it gives an alarm. So therefore, in order to perform a process like that, it looks for its outstanding alarm. So these alarms are always waiting. Now temporarily it suspends the printing of the page and it waits for you to just put down the paper or maybe load the ink or maybe just see that the printer is unjammed. And once the alarm is taken care of, it will come back and redo the process again. So it also has lists of all the related process. For example, if you need to do some print job, starts a process of print job, which is the one, it loads the driver, how the printer needs to be moved, everything. That is another process. So therefore, all the related process, it's going to maintain a list and it keeps with it. And all the other information needed to run the program. A process is basically fundamentally a container that holds all the information needed to run a program. The easiest way to get a good intuitive feel for a process is think about an example. Now suppose you are doing a video editing program and instructed it to convert a 1 hour video into certain format. The process is taking its own time. In this meantime, you remember that I need to search some web. So you go ahead and then you are just going to open some web page. Then some background process like an email process which pretty frequently or periodically wakes up and checks the incoming email. So now how many processes are running? Around 3 processes are running parallelly: a video editor, the web browser, and email receiver. Periodically, the operating system decides to stop running one process. For example, when you're running very heavy process like Visual Studio, which is going to take away a lot of CPU resources or memory resources, what it does is it will say that temporarily let me stall the process because it has taken up more than its share of resources like CPU time. So therefore, it temporarily suspends it. But I know that when you come back, it has to restart the process. For example, if you're trying to load a web page onto a local host, what happens? It started doing some things, but it stopped for some temporary time. And when you want to come back, it starts loading from where it stopped. Or maybe you are downloading a file. Suddenly your internet connection goes off. For that reason, it temporarily suspends process, and when the internet connection is revoked, it will restart the download process. It will not restart. Instead, it remembers where it stopped the download and it will continue the resume the download from there. Otherwise, if it is sending some WhatsApp message, yeah, initially because of slow speed or for some reason it didn't send the message. So what does it do? It again tries to resend when the internet connection is revoked. So, but how does it resume purchasing? So, it resumes this way because a process is suspended temporarily means it tries to remember its state. It has to remember where did I stop? When I come back, I have to start from there. A typical example is your YouTube video. When you are watching video for 10 minutes, you stop it today and you want to come back tomorrow and then rewatch the video. It will tell you that you stopped until this time. You can resume it from there. So that is remembering the state information. The operating system has all the needed data structures to remember the state of every process that is suspended. All information about the process must explicitly be saved somewhere during the suspension. Now, where is it saving? Now, your address space is something that remembers the instruction that needs to be followed. Stack has list of the instructions, and stack pointer points to the place where the instruction is presently resumed. Now, so it needs to have another data structure which stores the state information. The process may have several files open for reading at once. Associated with each of these files is a pointer giving the current position, that is, the number of bytes or records to be read next. What do you mean by number of bytes? Because every instruction might not be of the same size. When you go for machine learning class, he will clearly tell you which instruction is of which size. And sometimes the data that you store, it might not be of the same size as expected, because sometimes you might have array data also. Arrays whose size has not yet been defined. So therefore, every time to execute some instruction, it needs to know how many bytes it needs to read, so that the read call can be executed after the process is restarted. So all this information has to be stored somewhere. In many operating systems, all the information about each process other than the contents of its own address space is usually stored. What does the address space store? It is only the starting memory location and ending memory location. But there are many more things like data, and the present state of the system and many more things that needs to be stayed. So therefore it also maintains another data structure called process table. Process table is just an array of structures, one for each process currently in existence. So thus a suspended process consists of address space, usually called the core image, and its process table entry, which contains what all things does it store? The contents of its registers and many other items that are very much needed to restart the process later. Now, every process is associated with some set of system calls. So, to understand a system call, let us understand how a process prints a page. In order to drive a printer, I need to drive the printer's head. Printer's head is like sprinkling ink on a page. So it needs to drive the printer's head with certain signal which is going to move the head so fast so that the ink is sprinkled in such a shape that you get the letter or you get the image or so on. If you need to display something on your monitor, it needs to generate a signal, maybe a light spot which moves so fast that your letters are displayed on your screen. Now, how does it move? The movement is triggered by the nature of the file you are working on. The movement of the printer head also is triggered by the nature of the file that you are working on. So, to do so, it has to just invoke some assembly level program, or it needs to call some system call, which in turn will call the driver of the printer, which knows what signal it needs to generate so that the printer can accordingly behave. So therefore, every process is associated with some set of system calls. The key process management system calls, but whatever the drivers might have, let's not discuss it, that is beyond our class intention today. It might be taken care in some machine programming class, but right now the key process management calls are the processes called, the key process management system calls are basically the one that creates a process and the one that terminates the process. So for example, if you are talking about a process which is a command interpreter or a shell reader, what does it do? It reads the shell commands, for example, in a Linux terminal or in a Windows command prompt terminal. It needs to read one function and interpret every letter in the function, find out whether the compiler has such a function that is existent, whether the spelling is right, whether such a function is existent, and accordingly do what the compiler defines the function as. So therefore the shell must now create a new process that will run the compiler. First it needs to run the compiler, that is the compiler is open. Then it starts searching the compiler for a matching function like that. So what does the compiler have? The definition of every function. It's like a dictionary for a particular language. If you talk about Perl that is used as a language for Linux, it will have a dictionary words and the meaning of every word in the compiler. So when the process has finished the compilation, what does it do while it's doing the compilation? It matches for the function. It looks for what does the function do? Basically the needed instructions to perform that particular function. Example, if it gives dir, it will go and read the existing directory for all the file names that are present in that particular directory. If it has one file, it lists down or displays that file name on the screen. If it has 1 crore files, it lists down all the 1 crore files one by one, read everything, it takes slowly and does that particular process. Once it is done the compilation, then the process will be terminated. A system call called process terminate is evoked and that will terminate the process. If it is a print job or if it is displaying, every display will be stopped. If a process can create one or more other processes, they are called child process. As we discussed, if you talk about a C program, it has hash include, stdio.in, it has string.h, it has math.h, it's opening many more files. So opening a file is one process, reading that file is another process. Like that, it's opening 3 files and reading them one by one. So that all these processes which are invoked because of another process is called child process. Which is example, a payroll information, if you just look at, Every payroll has so many more things to do. In order to print your payslip, one has to know what all employee has done this month. Did he take any car loan? Did he buy anything from Amazon as an EMI? Did he just take any personal loan from our institute? Or did he just get any bonus from somewhere? Or did he just get DA arrears? Or did he just not supply any tax file because of which we need to cut a huge amount as a tax? All that information is stored in one file. So it opens all the files, it reads them and accordingly prepares the payslip. So if each child process creates more child process, a process tree is formed. As we said in a payroll, it's not just one file that is opened. It opens one file. In order to check that, it opens another file. In order to check that, it opens another file, like that. Every process is creating one child process. That means we have parents, grandparents, grandparents of the process. In such case, you have a process tree that is formed. So in order to close a process like this, we cannot right away close the grandparents process. We need to first close down the grandchildren's process, then we should close down the children process, then only we can close the grandparents process. So related processes that are cooperating to get some job done often need to communicate with one another. As we know, in a payroll, it needs to go talk to the tax file, open it, read its contents, get the employee's tax info, and then put it in your payslip. If it is a loan file, open that file, read the entire file, find out what this employee has done as far as his loan is concerned, what is the value, is he buying a car, did he buy Innova or did he buy Alto, how much EMI he needs to pay, everything it needs to do, read. So therefore there is a lot of inter-process communication that is going on. So this much inter-process communication has to be done using some robust algorithm. Let's discuss about inter-process communication and their corresponding algorithms in the next topic. Now, when the specified number of seconds has elapsed, when a process is doing an IO or memory read, etc., the operating system sends an alarm signal to the process. Now, when something happens and an alarm signal is sent, we need to have a system that can understand what this alarm signal is for and then accordingly act. That is called as signal processing procedure or signal handling procedure. So every operating system also has special signal handling procedure. So when I said shut down, it sends me an alarm saying that you have so many changes that are just made to some files. Do you want us to shut down the system immediately, or do you want us to wait for some time so that you can save those files? If a printer is not working, if the page is jammed, it gives you an alarm saying that the printer is not working, can you fix it? So it waits accordingly and it does handle the signals. For example, Windows Update, when it appears, it gives an alarm and it also accordingly handles the alarm. So for example, to retransmit a presumably lost message, for example, when it needs to resume a download, when internet has just shut down and it has to suddenly stop downloading of a file, shayad the process that is taking care of whether the internet connection is okay or not, that might give alarm to the other process which is downloading. It says that yeah, it has to stop the download because the internet has just been interrupted. When it comes back, it again sends an alarm saying that the internet is back, please resume the download. So now in this case, alarms are automatically handled. So therefore, the operating systems have some signal handling procedure which will take care of the alarms automatically. When a signal handler is done, the running process is restarted in the state. For example, when I say okay, that my printer is fine now, it will restart the process automatically. So, but what are these alarms? Are they hardware alarms? They are not hardware alarms, they are software alarms. They are actually written in software. How this kind of alarms needs to be handled, some procedure or some code is written down which is going to handle these alarms. Now, these are similar to your hardware interrupts. So in case if one chipset need to talk to the other chipset, it will send an interrupt in hardware. So, but all these chipsets are tuned to take care of every interrupt. Now, this interrupt is like a signal sent from one place to another. Similarly, software alarms are sent in software nature and can be generated by a variety of causes in addition of timers expiring. Now, the next important thing about process is user ID. Now, in case of Linux and Windows, every process is actually owned by a user. For example, when you are running a payroll and wanted to transmit some large amount from one organization into the organization's bank account, that is, the organization's bank account is one thing, it has one head from which the salary needs to be transferred to the salary account, or maybe from the salary account it needs to be transferred to every employee's individual account. That is a big process. It will run for hours together. Usually these processes are owned by the person, maybe the head accountant, who is going to initiate the process. So every process is actually has one user ID. The user who created that process is the one who is going to own the process. In Linux, when you use the ls command, it lists down lsl command, it lists down all the processes. It also tells you what are the user IDs associated. PS command, it will list down all the process and it will tell you user IDs who are owning those processes. Every process started has a user ID of the person who started it, and no other person can stop or interrupt such a process if it is owned by someone. It also depends on what kind of permissions are associated with that particular process. Now, if someone is starting a child process, that is a process which has been started by a user, if it starts a child process, the child process is also going to have the same user ID as the parent process. Now, suppose if this process is associated with some group of people, it will have a group ID. But in Linux and in Windows, usually there is one user ID which is called as a super user. This super user can override every protection rule the process has. In Windows it is called administrator. In case of Linux it is called as super user. He has special powers and he can override every protection rule these processes have. Usually otherwise there are more important processes like the payroll process or maybe a railway reservation process, etc. This kind of process cannot be interrupted by any other employee. Only the person who is entitled to run the process is the one who owns the process, and no one else can interrupt such processes. Now, every process, as we said, has an address space. It stores so many things like the block of the location address of the block of the memory which is associated with the process. It stores registers, names, the data that is holded by these registers, etc. Now, every computer has some main memory that it uses to hold executing programs. In a very simple operating system, only one program at a time is in memory. Examples are your embedded systems. Embedded systems usually has very little main memory block or very little main memory. It can hold only one single program. Until unless you just remove this particular single program from the main memory, it cannot just load a second program. Although if you look at your washing machine, it has many programs. But then given a time or a given instant, we can run only one program. No other program can be run parallelly. But Windows, Linux, or the desktop versions of Windows and Linux has multiple programs that are running in the memory at the same time. So to keep them from interfering with one another, some kind of protection mechanism is needed. Now you know in desktop versions we have so many processes which are running in parallel like WhatsApp, Excel, Word, maybe your email process, your Google Chrome, etc. etc. So if you start Google Chrome, does it interrupt your WhatsApp? It doesn't. When you start your Excel, it doesn't interrupt your Word program. But there are some programs which do interrupt others. For example, when you're working with SQL Server or some database program, and if you want to just launch your local website, it says that it has objections with the firewall program. Many times, many other programs also objections with the firewall program. whenever you are just downloading some new software, and if you want to just install that, it will say that let me make some changes to your system, and it does make some changes, and sometimes some programs stop working. And sometimes when you are just trying to restore your system or trying to repair your system starter, you might lose some of the installed programs. Yeah, some programs or some processes do interfere with some existing programs, but then in some most of the cases, at least the application software, just say these Word, Excel, Google Chrome, WhatsApp, they never interfere with other processes, and they are protected from each other. They are insulated. So while this mechanism has to be in hardware, it is controlled by the operating system. Most of the application protection mechanism, it is just embedded into the hardware. When it is embedded into the hardware, it is not controlled by the operating system. Managing the address space of process is also an equally important memory related issue. Examples of process, anyway, we have already discussed what are the examples of process. What is it? It's a word processing program being run by an individual user is a process. A system task such as sending output to a printer can also be a process. For now, you can consider a process to be a job as time shared program, but later you will learn that the concept is more general. So this has already been discussed. We said that process is associated with some addresses which start from 0 to some maximum. In the simplest case, the maximum amount of address space a process has is less than that of the main memory. Usually, processes are much smaller than the main memory. For example, even if the processes of your washing machine, if you want to, they are planned in such a way that their size is much less than the main memory provided. So whatever program you put in, woolen program, or you put in some very heavy soil clothes program, the program is completely fit into your main memory. That's it. But these days we are getting processors which are more heavier than the size of the main memory. So in such cases, if it were olden days IBM operating system or IBM's machine, what will it do? It will say that the process is too heavy and everyone will criticize the process and we just put it into the dustbin. But however, nowadays we don't do so. We have some concept called as virtual memory. Let's discuss it later. But before that, we should understand that what is the address space that we are talking about. So, what is the size of the addresses in case of the operating systems? Usually, most computers' operating systems, we call them as 32-bit operating systems or 64-bit operating systems. Whenever your computer is having a 32-bit operating system, the number of addresses that are possible are 2 to the power 32. If it has a 64-bit operating system, the address basically has a size of 64 bits and the number of total possible addresses are 2 to the power 64 bytes. If a process has more address space than the computer has main memory in olden days, we used to just exclude the process. Imagine how much criticism the IBM's first operating system has faced. It said that we don't want the crude stuff at all. The process is too heavy. Whenever some big problem comes up, people usually criticize the idea. But later on, they somehow come down with some solution. So for this huge and heavy process also people did come out. They created some new idea called virtual memory. Virtual memory is like this. Usually when the process is too big compared to your main memory size, what they do is they store part of the process instructions in the main memory and part in the hard disk. And then they keep executing the process in parts and parcels. The part that is executed is just sent back to the main memory, and the part that is not executed is reloaded into the main memory. So like that, it keeps swapping the code from main memory into the hard disk. And such a kind of execution process gives us an intuitive feel that our main memory size is much bigger than actually existent. And therefore, when they talk about or associate addresses with that, they give an address size which is much bigger than the main memory. And this kind of abstraction that is created is called virtual memory, and we call such memory as logical memory. The address space is actually decoupled from the machine's physical memory and may be larger or smaller than the physical memory. A process needs certain resources. We all know what resources it needs. There is CPU time, the memory, files, and I/O devices to accomplish its task. Now, these resources are either given to the process when it is created or allocated at a later time. Why later time? When you talk about arrays and all, whose size is not yet defined, in such cases it is only when we execute that instruction with appropriate data, then only we need to plan for the memory size. In such cases, it is allocated later. In addition to various physical and logical resources that a process obtains when it is created, various initialization data may be passed along. For example, consider a process whose function is to display the status of a file on the screen of a terminal. How does something display its status on the screen? For example, I was typing your notes, and every 2 days I come down and see where did I type, how long did I type, and then only after checking the status I continued or revoked my work. So to do so, I need to open the file, showing it on the terminal. So what does the process do? It goes ahead. I only need to click on the file icon. When I click on the file icon, it searches for the file, opens it for me. The process will be given the name of the file as an input, and it will execute the appropriate instructions and system calls to obtain and display the desired information. It never confuses. When I just click on a file name, it exactly gets only that file's contents and displays that for me. So the coding is why we need to read all this. We need to have an idea what code is put into the operating system. See, this process goes ahead, searches for the file, and it opens the file, reads it word by word, and displays it on my terminal. So when the process terminates, the operating system will reclaim any reusable resources. For example, I have associated some memory for it, I have given some CPU time, I have associated some I/O devices for its function. Now, it will say that now since your work is done, I take back my CPU time, I take back my memory, I take back my I/O devices also, so that I can just now connect them to some other process. So all the reusable resources like this are taken back. Of course, the files cannot be taken back. Although if the file is loaded into the main memory, it's just removed from the main memory, so that main memory resource it will take off, but file remains in the hard disk. So because file space keeps on expanding as we create more and more files. We emphasize that a program by itself is not a process. Usually processes are the ones which are in active state or the ones which are in passive state. As we discussed previously, usually we might be having lot many programs: Word, Excel, SQL Server, MySQL, and also Access. We might be having WhatsApp as well as Skype. We have Google Chrome as well as Edge, and we have hundreds of games loaded into our computer. But presently, either Edge or a Chrome. I use WhatsApp or a Skype. Maybe I use one email. Today I am seeing only Gmail. Maybe tomorrow I'll see Yahoo Mail. I work with Word file. With database, maybe I work with only SQL Server. I might not be using MySQL or Access. So whatever I am working, that is a process which is in active state. Whatever is loaded into my hard disk, that is a process in passive state. I loaded these application programs into the hard disk doesn't mean that all these processes are in active state. They are just sitting, sleeping inside my hard disk. It is only the one which I evoked and I put down in the main memory, that is the one which is in active state. Now, to perform a process or to execute a process, usually I need some thread procedures for performing or executing a process. Now, In the olden days, we had only single threaded process. In order to do a single threaded process, it's a very simple data structure that we need. What I need to do, because the process has some set of instructions, let us say some 10 or 100 instructions, all these are loaded into the stack, and there is one program counter that keeps pointing to the current working instruction, that's all. I only need one program counter specifying the next instruction to execute. The execution of such a process is sequential. What do you mean by sequential? It will first execute the first instruction, then it will execute the second, then third, and so on until the entire program is completed. Further, at any time, one instruction at most is executed on behalf of the process. Thus, although the process may be associated with the same program, they are nevertheless considered two separate. So we all said that in C, it needs to open many files and it needs to read those files like standard input file stdio.in. When it reads these instructions, what it does is it's going to attach them with the original compiler file. So when it is doing so, everything is a separate process. Every child process acts like a separate process. So when we said, we already differentiated difference between process and a thread here. So when all these act as separate processes, they are all demanding more resources from the operating system. So when a child process like opening a file is needed, it will say that which part of the file I'm reading. So therefore it needs to have its separate program counter, it needs to have its separate stack, it needs to have its separate address space and so on. So two separate processes in execution are the ones, even if it is a child process, they are all two separate processes in execution sequences. However, we have something called a multi-threaded process. When a process is a heavier process, usually these days, the operating system has used or developed a concept called multi-threading, in which two different modules of the same process are executed by two different threads. Now, what way it is different from two separate processes? In a multi-threaded system, it will never demand a separate address space. It only requires a program counter which will point to which instruction which thread is executing. So for example, the first thread must be pointing to the first instruction. Suppose the second thread is posted onto the second module, it will point to that instruction number. So therefore, in a multi-threaded process, we just don't have just single program counter, but it has a multiple program counters, and these program counters load whatever instructions they are executing parallelly. Then in operating systems, what is a basic unit of work? Usually the basic unit of work is measured as a process. Usually when we just look at operating system and trying to just study what's going on in my system, it will say that right now I have some 100 processes which are running parallelly, or maybe 10 processes which are running parallelly, out of which a few are system process, a few are user defined process. So therefore, what is a basic unit of work in a system? Process is the basic unit of a work in the system. A system consists of a collection of processes, some of which are operating system process, system process. For example, when you are just running a firewall or maybe running a printer, you don't have any control on these processes. It automatically does these processes because it gives a system call and it is executed automatically. So those are called system process. And the ones that are user defined, for example, when you want to work with a Word file or maybe an Excel file, it is you who decide which application program to open and what to work on. These are all called user defined process. Now all these processes can be potentially executed concurrently by multiplexing on a single CPU. For example, the operating system is responsible for, so in a nutshell, we can just say that when such processes are executed in a concurrent manner, then what are the activities of an operating system? Basically, when concurrent processes are occurring, it needs to schedule the process. which process needs to execute right now, which is in active state, and which needs to be suspended or which is in passive state. So scheduling process is the first job of operating system. It also needs to schedule the threads. Now when you say that it is a multi-threaded system, needs to just say which thread will execute which part of the code. So therefore, scheduling the thread is also part of the operating system. Then it also has a job to create a process, delete some process and so on. Whether it is a user process or whether it is a system process. For example, when you give a system call, the system process is invoked by the operating system. So creation, deletion is also part of its job. Suspending and resuming process. किसी process को suspend करना या फिर उसको revoke करना या resume करना, that is also part of the operating system job. So for example, suppose when you are downloading a file, your internet connection is interrupted, then automatically it stops downloading. That is a via system call. And when the internet connection is revoked, without user asking it to re-download or resume the process, it might start downloading. Or maybe a WhatsApp message which is actually sending and your internet connection is interrupted, it will say that it didn't go, but after some time you see that the message is sent. Email, it stores usually in the email, if it is unable to just send it right now, it stores in an output buffer. It is only after some time it sends that email without even the user asking to do so. So therefore such systems, I think we can call them as system process, because जिसमें यूजर का कोई रूल नहीं होता, ना ही वो किसी अपनी मर्जी से कुछ करवाता है. So there are also mechanisms for providing process synchronization. For example, when when a C program is run, it needs to read another file called stdio.in. It accordingly makes the first process wait until it finishes reading the stdio.in. Or maybe if a process is listening over the internet whether bandwidth is appropriate or not, if it is appropriate, it informs the downloading process saying that now the bandwidth is appropriate, so therefore you can go ahead and then download the file. So the processes which are concurrently running, they need to synchronize themselves, then only accordingly they can act. For example, if something is printing a page, your process needs to wait until one page is printed, then only it will release the data for the second page. Now, providing mechanisms for process communication. Inter-process communication is also managed by operating system. A batch system executes jobs, whereas a time-shared system has user programs or tasks. Even on a single user system, a user may be able to run several programs at one time. A word processor, a web browser and an email package. And even if a user can execute only one program at a time, such as an embedded device that does not support multitasking, the operating system may need to support its own internal programmed activities. For example, if you talk about your embedded device like your washing machine, what happens? When you just say you want to run one program, it will first fix its drum accordingly. Then it will open a process called loading the water, checks the water level, stops the process of loading the water. Then it will load additives which are just supplied like your surf or detergent or something, and it will see that whether the quantity is appropriate, then that will stop its process. Then if it is trying to partially pre-wash your system, it will pre-wash it for some time and then stop that process. Like that, whatever little process it has, it needs to perform all of them. We said that it is a single tasking system, but then many more processes are associated with even the single tasking system, such as memory management. Of course, it is doing memory management, it is doing many more process management. In many respects, all these activities are similar, so we call them processes. Everything that is done is called as a process. Now, even if a user can execute only one program at a time, such as an embedded device that does not support multitasking, the operating system may need to support its own internal program activities, such as memory management. In many respects, all these activities are similar, so we call them processes.